Hello everyone, this is Amit. I welcome you all in the video lecture series of the subject Operation Research. This is our 8th lecture related to the chapter Transportation Problem, in which we will study about transshipment problem. So let us begin our discussion with what is transshipment problem. So guys, we had seen in transportation problem we can only do shipments directly from supply points to demand points. The supply was given and you can do the shipment from that supply points to the demand points. But in case of a transshipment problem, there is some modification. Here you can even transport from source to source as well as from destination to destination. So this is the difference between transportation problem and transshipment problem. In transportation problem, you can only do shipments from supply points to demand points. You can directly supply from supply points to demand points directly. But in case of a transshipment problem, here there is a bit of modification. Here the supply points can also supply to various supply points, as well as the destination points also can supply from destination points to some other destination points. So this is the basic difference between these two. So there are some basic definitions. Supply points, we will see one by one. It can send goods to another points but cannot receive goods from any other point. Then there is demand point. It can receive from other points but cannot send goods to any other point. That is demand point. Then transshipment point means it can receive goods from other points and send goods to other points. It can receive also and it can send also. So this is about transshipment point. It can do both the things. The transshipment points can receive also and can send also to other points. It can do both the things. It can receive from other points and send goods to other points also. Whereas in case of supply points, it cannot receive from any other point. Demand point, it cannot receive good from other points. But in case of a transshipment problem, it can do both the things simultaneously. It can receive also and it can send also to other points. So moving to our next slide, solution of the transshipment problem. So what are the steps that is used to solve the transshipment problem? So the first point is, wherever it is necessary, if the problem is unbalanced one, then one can add dummy point, that may be a demand point, or that may be that may be a demand point, or that may be a supply point, based on the requirement. According to the requirement, you can add dummy demand point or dummy supply point to make the problem a balanced problem. So, and that values of that cost will be 0, so it doesn't affect the final solution, but we are just adding it for doing the problem as a, or for considering the problem as a, or we are just balancing the problem by adding the dummy demand points or dummy supply points. Then let S is equal to the total supply available. Let S is equal to total available supply. Then construct a transportation problem or the table given according to the data, and then each supply point will have a supply equal to its original supply, and each demand point will have a demand to its original demand. Then let S is equal to the total supply. Then in case of this transshipment point, then each transshipment point will have supply equal to original supply plus total available supply. So there will be transshipment points where the supply points will have the supply that is available for that original supply plus total available supply will be added to each supply points. Similarly, each demand points will have demand, original demand plus total available supply will be added to this demand points. So that points are called transshipment point. Transshipment point will have supply. Each supply point will have its original supply plus total available supply, and each demand point will have original demand plus total available supply will be added to both the points. So such points are called transshipment point. So for better understanding, we will go through one example for your better understanding. So let us move towards the example. Okay, so this is the data that is given to you. A firm has two factories. There are two factories, X and Y, and three retail stores, A, B and C. The number of units of a product available at factory X and Y are 200 and 300 respectively, while the demand at retail stores are 100, 150 and 250 respectively. Rather than shipping directly from sources to destination, it is decided to investigate the possibility of transshipment. Find the optimal shipping schedule. The transportation costs in rupees per unit are given below. So one need to find the optimal shipping schedule, and the transportation cost in rupees per unit are given in the table which is given below. So this is the data that is given. There are two factories, X and Y, and there are three retail stores, and their demand is given as well as the factory's supply capacity is given. For X it is 200 and for Y it is 300. While for demand points, or retail store is having three demand points, that is having demand of 100, 150 and 250. So this is the data that is given to you. So let us first start our solution by checking whether the given problem is a balanced problem or not. So this is the data. Now in this problem you will come across the word transshipment point. Transshipment point is nothing but the supply points. Suppose here there are two supply points, X and Y. So whatever is their original supply capacity will be added with total available supply. It will be added with total available supply at each supply point and as well as at each demand point. So checking whether the problem is balanced problem or not. So you can check the X capacity of supply is 200 and Y it is 300. So 200 plus 300, that is 500. Then at the same time demand of retail stores A is 100, for B it is 150 and for C it is 250. So 100 plus 150, that is 250, and for C it is 250. So 250 plus 250 it is again 500. So supply capacity and demand is equal. So we can say that our problem on hand is a balanced problem. So let us move towards the second step. Now add the value of B to all the rows and column values. B or S, you can use any nomenclature, you can use any notation. B or S stands for total available supply. B or S stands for total available supply. So again I have drawn the table which was given in the data, and I have interpreted, I have put down the values that was given to us. So the factory X capacity was 200, factory Y's capacity was 300. Now what we have done according to the second step, add the value of B to all the rows and column values. B is nothing but total available supply, and that we will add to each row and each column. Okay, so it was 200 that was given in the data, that total available supply is 500. So we will add this 500 to this original 200 capacity, so it becomes 700. Similarly for factory Y it was 300, and we have added the total supply, that is B or S, whichever you can use as a notation, it is up to you. So that 500 is again added to this original supply capacity and becomes 800. Now the retail stores, that was A, B and C, its capacity its demand was 100, 150 and 250. So we will add that 500 to each demand points. So for A the demand was 100, original was 100, plus we will add the total supply, available supply, so it becomes 600. Here it was 150. We will add to that original demand point, the total supply available, that is 500, so it becomes 650. Similarly, it was 250, we have added 500, so it becomes 750. Now here retail stores was not given, any capacity was not given, so we will add total supply, total available supply. So it is 500, again 500, and again 500. Here also we will add 500 and 500. So this is how we have obtained this table. Now finding out the initial basic feasible solution using WAM method. You can use any method, northwest corner method or least cost method. It is up to you, but I have adopted WAM method because it gives you more closer solution to obtain the optimal solution. So this is the table. I have rewritten it. I have put all those values that was as it is, and I have rewritten the values of supply 700, 800 that was obtained from the above table. So it is 700, 800, 500, 500 and 500, 500, 500. So now moving to the next slide. This is the table. Now according to the WAM method, we will find the penalties of rows and columns individually. So by finding out the penalty of this X row, first row, the smallest element is 0 and the second smallest element is 6. So the difference of that two will give you 6. Similarly for Y row, the difference of the two smallest is 3. For here it is 1, here it is 1, and here it is 6. Similarly the column penalties we have find out. The lowest element or the lowest cost in the column X is 0 and the second lowest is 1. So difference of that two, it will be 1. For Y it is 2, for this A it is 1, for this B it is 4, for C it is 1. So now you can see there is a tie among the penalties, both are 6. Now to select which row, now if there is a tie among the two penalties, so if you see in this particular first row, the smallest element is 0. So if you we will have to do the allocation from the lowest cost cell in that particular row having the largest penalty. So here if we allocate in this particular cell, then from 700 and 500 the lowest allocation that can be done, that is 500. So you can allocate 500 over here. Similarly in this case, if you go with the fifth row, that is C, row C, then here also the smallest element is 0. So from 500 and 750 the lesser value that will be allocated, that is out of 750 and 500 the lowest value is 500, so we can allocate 500 over here. You can randomly do over here in this case also. So I have allocated 500 over here, and you can see now the supply capacity of C is now exhausted, so it becomes 0. And here it was demand of 750, but we have allocated only 500, so still 250 remains to be satisfied. So when we draw the next table, that will be our reduced table. In that, this C row will be deleted. So this is the reduced table that I have drawn. Same procedure has been followed. We have calculated the penalties of rows and columns that we had discussed earlier. So you can see now the penalty of X row is having the largest penalty among all the penalties that we had find out. So it is 6 over here. Now we will start doing the allocation in that row having the lowest cost cell. So it is this 0. So out of 500 and 700, whichever is the minimum, that value will be allocated. So we have allocated the lowest value, that is 500. So now here supply of 200 still remains because we have just utilized 500 only. So 200 will remain still the supply capacity of X, and you can see the demand of X column, that was 500, that is already satisfied. So it will become 0, and we will delete the column when we redraw the table in our next step. So let us move to the next step. This is our reduced table. Now you can see the X column is deleted. So again we had find out the penalties as per the procedure that we had discussed. You can see from this X row the smallest element is 6 and the second smallest is 7, so difference will give you 1. Among this 0 and 3 we will take the difference, and it is 3. Again 1, 1. Of the column we can find the largest penalty, we can find that is in the third column, B column. so that is 4. So we will do the allocation in this particular column. Now the lowest cost cell in that column B is 0, 5, 4, 8. So lowest is 5, sorry, the lowest is 0 among all the cells with lowest cost. Now you can see it is 500 and 650. So among 500 and 650 the smallest value can be allocated. So we are allocating 500. So this supply capacity of B becomes 0, and here it remains still the demand of B store with 150 demand remains. So here it is 150. So this row will be deleted when we redraw the table in our next step. So that will be our reduced table. So that is step 6, in which the row B is deleted and we are redrawing the table. That is our reduced table. So now it is other values are as it is. The supply capacity of X was 200, that is as it is. The supply capacity of Y is 800, that was as it is, and A, that was 500, that is as it is. The demand of Y was 500, that is as it is. Of A it was 600, that is as it is. Now for B now remains demand of 150, and for C it is 250. Again calculating the row penalties. The smallest element in that X row is 6, second smallest is 7, so difference is 1. Similarly for Y, the smallest is 0 and the second smallest is 3, so difference between that is 3. Then in this particular row it is 1. Then finding the column penalties, that is as we had discussed, the smallest element in Y column is 0 and second smallest is 2, so the difference of that 2 will give you 2. Similarly for this A column, the smallest element is 0 and the second smallest is 5, so difference of that will give you 5. Then in this the smallest element is 4 and the second smallest is 5, so difference will give you 1. Then in this 1 is the smallest and the second smallest is 3, so difference of that will give you 2. Now you can see the column A column is having the largest penalty, so we will select that column for doing the allocation. Now for that column we will identify the lowest cost cell for doing the allocation, so that is this 01, that is the 0 wala, and from 500 and 600 the lowest value that can be allocated, that is 500. So you can see now A, so for A you can see that its capacity is exhausted, so it becomes 0, and here the demand was 600 but we had allocated already 500, so now still the 100 demand remains, so that we must satisfy in our upcoming steps. So our next step will be the reduced table with the A row that is deleted. So moving to the next step, that you can see over here, X and Y, all the values are as it is, and we have find out the row penalties and column penalties. So you can see that there are tie among these column penalties, both are having value 6. So if you go for this column to do the allocation, then from 9 and 3 the lowest cost cell is 3. So from 800 and 250 the lowest allocation that can be done, that is 250. You can allocate maximum 250 over here, but if you go with this column then the lowest cost cell is 0, and from 800 and 500 you can do the allocation of 500. The lowest among 800 and 500 is 500, so you can do maximum allocation over here if you go with these column, and that will be our main task. So in case of tie you can select the column or row in which you can do maximum allocation. I had gone with this because the only reason is that we can do maximum allocation in this particular column, that is 500. If you had gone with this particular column, then you can do maximum allocation of 250 only, but in these if you are going with this column then you can do allocation of 500, which is larger than 250. So that's why I have gone with the allocation in this particular column, because we can allocate maximum. So now this demand of Y is satisfied, so it becomes 0. So in our next reduced table, but here still the supply of 300 remains, so this column will be deleted when we redraw the table, that is the reduced table, and that is over here. Now remains A, B and C column. Again finding out the penalties and of rows and columns. So we can see now that the column C is having the largest penalty, that is 6. Lowest cost cell of 9 and 3, lowest cost cell is 3 among that column. So from 300 and 250 the smallest value can be used to do the allocation, so we have allocated 250 over here. Now it becomes 0. Still here the supply capacity of 50 remains. So in our next step we will reduce table will be with without the C column. So that is over here. That is our 8th step. Now finding out the penalties of rows and column. Again it is 1, 1, 2 and 4. So you can see 4 is the largest penalty among all the penalties that you had find out. Now in that particular column, the lowest cost cell is this 4. So among 50 and 100, the minimum value is 50, so I have allocated 50 over here. So you can see now why supply capacity is exhausted and it becomes 0. So here now it will be 50. So moving to the next step, this is our next step. Now only one row remains. So that our lowest cost cell is this 7. Supply capacity of X is 200, whereas demand of A is 100 and of B is also 100. So the lowest cost cell in this X row is 7. So demand is 100 and supply capacity is 200. So among 200 and 100, the lowest value will be used for doing the allocation. So that is 100, that is I have allocated over here. Now you can see, okay, A column's demand is satisfied, so it becomes 0 and that A column will be deleted, and we will redraw the table in next step. So that is this step without this A column because its demand is already satisfied. Now supply remains 100 and demand is also 100. We have only one cell, so you can allocate that 100 in that cell, and now you can see demand is also satisfied as well as supply capacity is exhausted of all the factories. Simple thing one must keep in mind, the transshipment problem is nothing but each source point, each destination points are free to do the shipment wherever they want. There is no any restriction. Whereas in case of a transportation problem, the sources are supposed to do the shipment to destination points only. But in case of a transshipment problem, you can do the shipment from destination to destination, from destination to supply points, from supply points to destination, or from supply point to supply points. So this is the difference between transshipment problem and transportation problem. Now we will stop doing the allocation because all the supply capacities are exhausted of all the factories. Now this is the main table. We have redrawn it and I have allocated all the values that we had obtained during the various steps. So you can see over here the diagonal values will be ignored because it does not affect the final results, because all the unit cost of transportation is 0 along the diagonal. So multiplying that with any digit will not affect the final answer. So this diagonal values are ignored because all the unit transportation cost Cij is 0 in that diagonal, you can see over here. So now finding out the total transportation cost, this values shown in the round, that is Xij, number of units to be transported. So multiplying that all the values, you can find out that total transportation cost will be 2450. That is the total transportation cost, 2450. Now in which way or in what pattern the shipment takes place, let us see. Factory X supplies 100 units to A and 100 units to B each, and factory Y supplies 50 units to B, and factory Y supplies 200 units to C. So that is how the shipment pattern is obtained in this particular example. In this case we have not we did not get the supply from you can say from destination to destination or from source to source. So it can happen in the another examples. If you solve some more examples of transshipment problem, then you can find that in transshipment problem the shipment can take place from source to source, from destination to destination also and from source to destination also. So this is all about the transshipment problem. I hope you would have understood now the difference between transportation problem and transshipment problem. Thank you.